Yes, hello, a warm welcome to you. Yes, today we're continuing with the topic of thin sheet metal, but this time with flux-cored wires. Today we have the Parkside PMSG200 A1 on board again. That is basically the successor to the Parkside PMSG200 A1. Yes, I have flux-cored wire in 0.6 millimeters and 0.8 millimeters. You see, well, these rolls were just lying around somewhere at my place. I'm not really a big fan of flux-cored wire. But the wire is still fine. You can definitely weld with it. The roll is broken here, but that won't stop us from being able to weld properly with it. Yes, flux-cored wire is actually a good invention for welding outside where it's windy. It's perfectly suited for that. The rutile filling in the wire ensures that my weld pool is protected from the atmosphere. If I had a MAG welding process and were to weld outside, well, the wind would basically blow away my shielding gas. And the atmosphere would then have the chance to reach my weld pool, and then porosity would occur. That's why flux-cored wire was invented back then. And yes, it works too. The question for us now is, does it also work with thin sheet metal? I have the 0.7 sheet metal here, again, I guess a standard thickness in the automotive sector. Yes, and we'll use that for our tests. We are starting now with the 0.6 millimeter. It's a Parkside wire PSFDA1E71TGS. Yes, and I'll clamp that in now. But before I do that, we naturally have to make sure that we reverse the polarity, meaning with flux-cored wire, I have to polarize differently than with MAG wire. So I'm polarizing my hose package with negative and I've put my ground clamp on the positive pole. That would be the first step to weld flux-cored wire properly. Yes, then I'll insert the wire now. So there are two things you mustn't forget. You naturally have to adjust the drive roller according to the wire diameter. That means I have 0.6 wire here. I've turned the roller now. So I have two grooves on it. On one I can weld 0.8 to 1 millimeter, and on the other I can weld 0.6 millimeter wire. So the second thing you have to consider is don't forget to adjust the contact tip to the wire thickness. That means I previously had 1 millimeter on it. I've now screwed on the 0.6 contact tip. So, and then you can use the 0.6 wire quite well, I think, without any problems. Now for tacking, I'm using 13.9 volts and 65 amps, as you can see on the display. So tack welding with the 0.6 wire actually works very well here. Once we clean it up, you can actually see that the tacks have formed a good bond. It's really solid. Yeah, and now we could of course try to, well, do a fillet weld here as well. Though with such thin material, you'd probably do step welds instead, otherwise it gets too hot and we'd have extreme welding distortion. But for tacking here, 0.6. Very nice, and yeah, no problems with this setting. Now for welding the fillet weld, I've lowered the current a bit to 55 amperes. I hope it works. So you see, it worked at first, but then I made a hole in the back and then it just gets to be too much. Well, then it warps way too much. You can see this wave here in the front, but short step welds like this could definitely be done pretty easily. But I think that's about all you can get with the 0.6 flux-cored wire. And yeah, I'm going to tack a few more sheets on top now to see if we can confirm that we can make good tacks with the 0.6 wire. So tacking, I must say, actually works quite well here with the 0.6mm wire. Also relatively quickly. And I'm getting a really stable connection. So I've just placed 2 sheets on top of each other here, and I'll try to join them with tacks now. So this is relatively simple. So that works quite easily. Just put dots on it, and as you see, even welded through, we can go down a bit with the current, but that's a really good, solid connection. So that works with the 0.6 wire without any problems. So now we're going to convert the whole thing to 0.8 and see what advantages we have there. Now for the 0.8 flux-cored wire, I've chosen 13.9 volts and 70 amps. Much more isn't possible because then everything becomes too strong. And yeah, that's not possible at all anymore. So I'm starting again with tacking, and then we'll try the fillet weld. So tacking worked for a start. Although I have to say, compared to the 0.6 wire, it didn't feel as good. I couldn't control it as well. Also the spatter, as you can see here, there was quite a lot of spatter. So I've increased the voltage now. Let's see if it gets even better for tacking. You could use it like this, but well, I'll see. Yes, so if I increase the voltage, it gets better. So 14.6 volts, 70 amps for tacking. But as I said, you know, it's really not quite as elegant, refined and fine as it was when we used the 0.6 wire. So if you look at the back now, you can see here where I have the middle, the 3 pieces, those were the ones that had a bit more voltage. I've already gone through quite a bit there. So that means I'm definitely going back to my 13.9 and 70 amps for welding. Yes, it's also similar to the 0.6 wire, even a bit more critical. Yes, of course, I have even more current. So I've already got far too much energy in here. And yes, that's why after a short time everything gets too warm and then I make holes in it. So my first conclusion is that the 0.8 wire is absolutely and totally unsuitable. If you really want to work with thin sheet metal, then you use the 0.6. That's why I'm putting the 0.6 back on now to show you how I'd go about it if I were to weld something. So what's actually possible with the flux-cored wire? Well, with flux-cored wire at this sheet thickness, let's be honest, the most you can do is tack welding. And then, as I said, only with 0.6 wire. So 0.8 is already quite bad there. 0.6 wire actually works quite well for tack welding. And then if we want to weld something really stable, we have to do step seams. That means about 1 centimeter or so, or half a centimeter at most. So, setting tacks works really wonderfully with the 0.6 wire. So if that's enough for you and you just want to tack a few sheets on your car, that actually works wonderfully in any position with my settings. So what else can I do with the flux-cored wire? With the flux-cored wire, as mentioned before, I could now make short step seams. That means I'm going to try to pull 3 little seams here to secure the whole thing. Now I've turned the sheet metal over. Now we can just do the step seams on the back side. So that's what it looks like. I have a relatively high level of stability there. Okay, I'm going to turn off the machine. So I'll come to the conclusion now. Yeah. So flux core in general, as I said, I'm not a fan of it, but whoever absolutely has to weld with flux core because they're welding outside and let's say welding thick sheets, or let's say from 2 millimeters up, I think it's not a problem at all anymore. They'll really enjoy using flux core because it actually works quite well. When welding thin sheet metal, as I said, you can't really call it welding as such. It's more like just tacking, and short weld joints like the ones I've made here are absolutely possible. But as I said, only with the 0.6 flux core wire. So 0.8 doesn't really work at all. And yeah, for whoever that's enough, as I've shown it now, those are, I'd say, good joints. So it's not something that's going to break here. I mean, you can really massacre it. So it holds, it's actually completely sufficient. For them, it's good, of course. They don't need to buy gas, and then if they want to weld something, they can get it done. Yeah, and then I'm actually already at the end of my flux core topic for today. I hope you enjoyed it. Yeah, thumbs up if you liked it. Leave a sub so you don't miss any videos. And I'd be happy if you watch the next video as well. Take care. See ya. Bye.